In this problem we want to find derivatives by using the quotient rule, and so we'll start letter A. Our numerator is always the f in the formula for the quotient rule, and our denominator is always g. So we'll call this guy f, we'll call this guy g. F prime is equal to 1 and g prime is equal to 2. And the quotient rule says that if h of x equals f of x divided by g of x, then h prime of x is equal to f prime g minus f g prime over g squared. So this is the formula. Now we can do f of x, g of x, f of x, g of x, but I just don't have enough room. So this is basically what the quotient rule says, that we can find the derivative of a quotient by applying this formula. So in this case, h prime of x is going to be my f prime, which is 1, times my g, which is 2x minus 4, minus fg prime, which is x plus 1, that's f. G prime is 2, all over g, which is 2x minus 4, quantity squared. So we can reduce and everything if we want to. We'll just go ahead and leave it alone. Letter B, h of x equals x to the third minus 2.2x over 3x squared plus 2x. So this is our f, this is our g, and we have f prime equals 3x squared minus 2.2, and we have g prime equals 6x plus 2. So that means applying this into our quotient rule formula, we have h prime of x equals f prime g, which is 3x squared minus 2.2 times g, which is 3x squared plus 2x, minus, I'll just write this on the line below, fg prime, which is x to the third minus 2.2x times g prime, which is 6x plus 2, so I'll put that down here. And I'm going to divide this whole thing by g squared, which is 3x squared plus 2x, quantity squared. So that's that whole thing. And we're done with that problem. So now we'll move on to letter C, which is, we'll do on the next page. So we have C h of x equals 2 to the x divided by x squared minus 4. And so again, we'll identify our f of x, we'll identify our g of x, and now we'll find our f prime, which according to the exponential derivative rule is natural log of 2 raised to the 2x. And g prime is going to be just 2x. And so now we put this all together for h prime of x, and we get f prime, which is ln 2 times 2 to the x, times g, which is x squared minus 4, minus fg prime, which is 2 to the x, g prime is 2x, all over g squared, which is x squared minus 4, quantity squared. And we're done with that problem. So next we have 2 to the t minus ln t over t to the fourth minus e to the t, which actually from previous question is very similar, except that it's in the quotient form instead of a product form. So 2 to the t minus ln t, t to the 4 minus e to the t. And so there's our f, there's our g, f prime. We got to use the exponential and logarithmic derivative rules. So we'll have ln 2 times 2 to the t minus, this will just end up being 1 over t, because we'll have 1 over ln e times t, and ln e is 1. So I'll just go ahead and jump to the simplified form. And you can take a look back at the previous problem and see how we found the derivative. And g prime is 4t cubed minus e to the t. And so now we put it all into the d prime of t into our quotient rule form, and so f prime g will give us ln 2 to the t minus 1 over t multiplied by g, which is t to the 4 minus e to the t, minus fg prime, which is 2 to the t minus ln t, g prime, which is 4t to the third minus e to the t. I squeeze that in there, and all divided by g squared. So t to the 4 minus e to the t quantity squared. And we're done. That's a very long derivative. However, just keep in mind that it is what it is, and we don't really have to manipulate this too much unless we want to find the derivative at a specific point.